Hello and welcome to another session. It's been a while. We had a discussion on some of our systems. The last time we talked about was on the fuel system. We touched on the mechanical fuel systems. We touched on the conventional fuel system, which uses a fuel tank, a primer, electric or hand primer, a transfer pump, a conventional injection pump, pumps, lines, and then nozzles. And we are going to elaborate into details about the conventional pumps and line injection system. Now, like all other fuel systems, the aim is to deliver a precise, fine, and minute particle of fuel into the combustion chamber in order to aid proper combustion and produce power. And the function of this fuel system is to pick up fuel, clean it, pressurize it, and send it to the nozzle in order to be sprayed into the combustion chamber, depending on the needs and the load placed on the engine. Such is the precision being implemented into producing or manufacturing the fuel system. Now, the basic components of this conventional fuel system is the storage tank, the hand primer, the primary filters, the secondary filters, the transfer pump, the injection pump, the governor, the lines, the pressure lines, and the nozzles. We are going to talk about these components one after the other. The first component, we talk about the tank, which we say is the storage. It's used for storage, and this tank has baffles built in to ensure that the fuel does not dangle back and forth, which makes the particles maybe that are settled under the tank to mix with the fuel. Now, this transfer pump draws fuel from the tank through the inlet port of the filter and transfers it to the injection pump. Now, after the fuel flowing through the primary filter and reaching the transfer pump, it is now pressurized by the transfer pump through the secondary filter to the injection pump. Now, this fuel is delivered to the fuel section of the injection pump. This element comprises of a plunger and a barrel with a delivery valve, which ensures that there is always a pressure left in the pipelines to ensure that the next injection is smooth and perfect. And in each pump unit, if there are 3 cylinders, each cylinder has got to get its own injection pump. But these are combined into one with one camshaft that drives all, but each has its cam lobe that drives it according to the firing order of the cylinder. If you have 6, 3, 4, 8 8 cylinders, you have similar number of injection pump units: 8, 3, 8, 4, 12, etc. The governor controls the amount of fuel delivery required to maintain engine speed as load demands change. Any excess fuel in this injection pump is sent out through the outlet line back to tank. Now, there is a rack that controls this plunger. Rotating the plunger increases or decreases the amount of fuel that is injected into the cylinders, or the amount of fuel that is sent to the nozzles to be injected into the cylinders. This rack is controlled by the governor so as to control the speed according to load placed on the engine. Now, the high fuel lines that transfer the fuel from the injection pumps to the various nozzles are made of equal length, no matter where the cylinder is from the injection pump. So even the closest to the pump still has the pressure lines of the same length as that further away from the pump. If one pipeline is longer than the rest, the amount of time, the amount of extra time it takes to reach that nozzle could change the fuel injection and the timing. You could see that the fuel lines has got a lot of bendings before it reaches the nozzle. So as all of them to be of the same length. So the one closest to the pump has a lot of bends, whilst the one furthest away from the pump has very few bends because it needs to go an extra length to catch up with the rest.